Okay, so this equation asks us to give both the x and y intercepts of a particular function. Try and go back to meaning here, right? If I draw this line, that line, well, that's a whole bunch of lines. Let me just draw one line. If I draw this line, right, as I am along the line here, there's a y value that's positive, a y value that's smaller, a y value that's smaller. And then over here, the y values are negative, right? You can see y's are negative. Now, as I go across this line, as I cross the x-axis, that's my x-intercept, when that happens, y takes on one particular value. And in fact, the value y takes on is 0. So when I'm crossing the x-axis, right, when am at my x-intercept, y equals 0. So if I want to find my x-intercept, I simply begin by considering the case that y is 0. If y is 0, 3y is certainly 0. And this function, or this equation rather, becomes 5x equals 30. If 5x is 30, by the division property of equality, if I divide both sides by 5, I get that x must equal 6. So x equals 6, 0. This is my x-intercept, that location, right? Y is 0, x is 6. And I'm over here at 1, 2, 3, 4, 5, and 6. Here's my x-intercept. Similarly, when I'm crossing my y-axis, right, you can see here x's are positive, here x's are negative. At this moment, right here, as I'm crossing the y-axis, my x equals 0. So that's what I'm going to do to find my y-intercept. I'm going to let x equals 0. And when I let x equals 0, this equation becomes 3y equals 30. Therefore, y equals the number 10. So this point right here, x is 0, y is 10, is my y-intercept. And again, I'm going to graph that by just going up 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. Now that I have those 2 points, right, to finish off the graph, let me grab a ruler. Those are my intercepts, and I'm just going to go ahead and carefully draw the line that goes through them. So that's roughly the line 5x plus 3y equals 30. It was written in standard form, and we've produced the graph for it. Right.